Yo, 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 let's jump in. The idea was to start it a little bit quicker today, because just like yesterday, I won't be able to stream as much today, and I want to get some stuff done. Good morning, by the way, Smack GDs, and good luck with the actual work today. So, we're in the process of converting the Fluids implementation from a class-based solution basically to a texture-based solution. Like, we want to go through everything in it, but we want to do it with a texture. And the reason for this is that we're going to pack a lot of data into the texture, which we can hopefully use at a later point to make some animations and stuff like that. And it always was the idea to alter the terrain data container directly instead of instantiating a bunch of custom classes. So right now we have terrain data container had previously it only had a one texture 2D data, but now we have introduced a new one. Although not extremely happy about this one. I would like it to be more general. So maybe we would have a primary data, secondary data, or we could just have data and we have a texture 2D array on the CPU. But the problem is then we introduce a terrain data type, enum, which we use to get and set stuff. The only problem with that, however, is I'm not entirely sure how we would do this, because if we take a look at the raw data of a texture 2D, it's stored as a struct color 32, which means that we can't change, we can't alter a specific color. Instead, we need to recreate the full new color 32, and we want to recreate it from the previous one, and so it's pretty much how one would do this. We could do it with some multiplication, I guess. Because much like this one, I think best case scenario, I would like to have something like this. Public byte get data int x int y, and then I would like to have terrain data type dot height, for instance, or that is how you would call it, but we could do it like something like this. So this is what I would want to have. But good morning, Geralt. You can switch on enum and have different behavior. Yeah, like we're working with raw data here. We want it to go extremely quick as well. But like, which switch is, but, and then I would like to have something like this. Let's see here. Data type dot Uh, let's see here. We can do texture index, and then I want to type channel index. I think this is how, or it's actually going to be y times data type.texture index dot plus x it would actually be like this. I wonder if this is how I want it. The problem is when we're gonna assign values, because then we have this. Let's see here, set data int x, int y, terrain data type value. This is where the problem begins, because this one is a struct. So you would like to do this again, and you would like to do equals see here. My question, we could make it And this, we can't do this. So that's the problem. When we do a sign, we have to do it. We have to create a new color 32 struct, and we need to alter it in some way. What constructors do we have? Color 32. You could do something like this, but I'm not a very big fan of this, I don't think. Like, this is all... This looks very clean. Okay, I think we can do like this. Like, you could use a... Could do color 32 dot scale, no. But we could use type dot r times value plus type type R actually. Like a bad way to do it, I would guess, would be something like, let's go R change plus times value plus color 32 old value or old data get data xy type like something like this. But then again, this feels like one hell of a workaround. Like, all it comes down to is, if we had it like this, it would be very nice from the outside. We would add some overheads though. This is yeah, I just think this comes with too much overhead. First of all, this instead of this. And then we also have the type, depending on how we implement this, for instance. So let's assume that we do it the classical way of using extension methods for enums, which switch cases. So this is one switch case. Another switch case, another switch case. So it's either something like this with terrain data type enum, which defines what type of data is in what channel and so on, or we just do it like this. So if we don't do it like this, but in like this instead, that means that we're gonna have 8 getters and setters. And the only we could have what the fuck, I think we're gonna do it like this. Yeah, we're gonna have an enum, we're gonna skip this, we're gonna have one getter, one setter. Getter is gonna be easy, we're just gonna take the enum value here, pretty much. Setter is going to be a switch. So so one switch. I think I'm okay with that. So I want to introduce terrain data type. And we're gonna do height 0. I think. But then again, Yo, what's up, Harry? It's going pretty good here, I think. How about you? We still have the problem of... No, we don't. Unused 1 RGB. Unused 1A. And okay, speaking about water states, we want to represent like when I'm thinking about this, so we're basically gonna have one texture that is one whole texture, so 32 bits to represent water at a certain point. And we're gonna need, depending on how explicit we want to be with the animation, I would like to have... What the fuck, what would I like to have? Let's see here. Pack direction into 8 bits. What is the best way to do this? Or pack 3D direction into 8 bits. It's too optimistic, right? It's way too optimistic. Actually, it might not be. Harry, did you get the water going good? Not yet, not yet. Like, the initial simulation works very well. We get water. We can calculate where. Sorry about that. We can calculate where the water will end up and how it will end up. So that one is looks very good and nice. And now we're in the process of improving the algorithm, both in performance and in how the code looks. We want to make it cleaner, basically. But while we're doing that, we're also prepping it for actually rendering it. And that's why we're working with data now. Which data will we need? How will we need it to make it look good in the end? This is very interesting. Mm-hmm. We could. Packing in a direction into using two floats should be pretty easy, I think. We could just do two dots, I suppose. Because in the end I would like. Okay, so when we look at the actual terrain, the terrain gets its tangents and its normals from the mesh itself. But when it comes to water, I think I would like to calculate that in the shader. Packing it into a texture like normals and maybe even tangent would be nice, instead of having to check neighbors. But I don't know if that's the way to go. We could just ignore normals and tangents for now, possibly. Let's see. I think I would be okay with this. Truncation for water. Mm. Maybe this is the way to go. The only problem I have with this, so we will pretty much have a height map for the water as well in a texture, and then when we render the texture we calculate the normals and tangents and whatnot on the GPU, but that means that for each vertex we need to read 9 values and do a lot of calculations for them. Each frame shouldn't be too costly, but okay, so if we ignore the cost of it, then we have the problem with patches in our case. Like we're missing at the edges of a patch, we're missing some information in the texture. That's a pretty damn good result. I wonder what would be quicker, changing the mesh or okay, I need to think about this part. We can continue without that one for now though, I think. So if we disregard normals, we're gonna need them, but how we get them isn't fully decided yet. Either we do it by height, a height map on the GPU side, or we do it, or we calculate it per vertex on the CPU side when we change stuff. And then there's also a question of, okay, so let's assume that we offset the mesh on the GPU side. So the water is just a plane, and then we offset the vertices in the plane on the GPU side. That means that we can never, let's see here, could we do that either way? Like I have questions about the culling of the mesh. And decisions. Okay, but what do we realistically need? What data do we need in the texture to be able to render? We want to make the transition from no water to water look sorta good. So let's disregard normals for now. Height difference we always planned to have in the texture. That's water amount per pixel. But we want to transition from one state to another state, which means that one channel also need to have the previous water state, because let's assume that we have water on the terrain and then we add more water. Then we want to pretty much lerp from one state to the other. So we need new state, old state. The initial iteration we do with the fluid solver figures out where water will end up. So, and I think I want that data to visualize a few things as well. So we're gonna need that as well. So old state, new state. Or actually, yeah, old state, new state, minima state. And then I need time as well. And that's all the 4 channels. And that sucks. Harry, can't you make a small prototype of each one, or would that take too long? To be honest with you, that is probably what we're gonna do. Much like we did with the terrain a few months back. But the way I like to do it is we're gonna do the simple way first and make it work, and then see if we can improve it. And the most simple thing would be height map on the GPU, I think. But if we take a look at this, like, we have 4 data that we need to store in this texture already. That means that we don't have any more memory to spare. We do have 2 unused one here though. But in the second texture we don't have any more memory to spare. What's up, Max Dennis Gun, by the way? How does the player look? We might take a look at that soon. Or actually, you should be able to see it on my YouTube channel, I think. Or I know. Ernest Dev, thank you for the follow, appreciate it. So I wonder if I want to have something like this. Water. Yeah, we can't really use this either unless we go for... Let's just do a switch case. Water, previous, maybe. Influx. Fuck, am I overthinking this? Do we have a simpler way to do this? Something like this. And then once again, let's say for instance that we could. Okay, so if we have it like this means that water can have 256 different height levels, right? We're using 8 bits per channel. Uh, 8-bit float precision. Mini float. I wonder how this would be. Like, we only want to represent values between 0 and 1 as well. Let's go with this. We know that this works pretty good. Water, water previous, influx, and timestamp. I don't know. Maybe. Terrain data container. Do we actually use this one here? Add Flu recursive CPU. So then it would basically be get data int index feels like I have a big design decision to take when it comes to terrain data. We want to make it so when the entry and exit points out of this class should be very abstract. Like, this is the only class that should know how the data actually looks behind the scenes. It should handle the conversion between two integer-based indices to one index-based, to check if something is in bounds. We don't really care about that, or we're gonna put it like this. Let's see here. Get data, set data, public bool in bounds, maybe. What's up, KXL? Terrain data type. The two different, these should have the same sizes, so we don't really care about that. So for now we could probably do where the goal is to remove all of these as well. They are related to the old stuff. So get data switch type get data, set data. Or here, for now we could actually do this. Default return this. Actually, so what is it? Oops. Return y times right. Although I don't know how much I want to use this one compared to just calculating this one inside. Oh well. So get data height, for instance, would look something like, let's see, data get pixel data color 32. But yeah, we want to go with index here as well. So get index. But then we introduce a new and 0. Yeah, just return 0. This one is a bit more complicated. It's going to be a lot of repeats. Then we want to add data as well, or subtract data, alter data, but we want to make sure we don't overflow or underflow. But it would be color 32. All data is equal to yeah, and I'm gonna name that let's see here, data array. all data is equal to data array at index, and then we do data array index is equal to new color 32 value all data dot g b a. So this is what we're gonna go through when we change the values. What screws this up the most, I would still say it's the fact that this one is a struct, but that's what we want to work with. It doesn't really screw it up, but it makes it a bit more obscure to work with. But let's see here. So we calculate index, we get the data array, the data array we're interested in. We get the old data because we only want to alter the channel based on terrain data type. And we're pretty much going to have to actually it depends if we want to introduce let's see here, we could do it like this. We could make it a little bit prettier by doing 0, 1, 2, 3, 4. So we could do terrain data type methods, and also I want to do public static class. We could do it like this. That will happen for us actually. So we do type 4. Oh no, it won't. Right, 0 becomes 0, 1 becomes 1, 2, 3, then 4 becomes 0 again. It's not texture index, but rather, could we do this? Channel index, public static int. Channel index is easy. Texture index. Return int type divided by 4, but then we're gonna have to do math f dot C# int division always floor. What the fuck? Or like into the division. Rounded towards 0. That's what I want to know. Rounded towards 0. But rounded towards 0. So that's what I want, right? So 0 divided by 4, 0, 1, 0, 2, 0, 3, 0, right? 4, 1, 5, 1. Shouldn't this be sufficient? I think it should. So then we can actually do this quite nicely. Except for, or can we? I think we can. So in bounds we can just do, and then if we store them in the same one, let's see, public texture 2D. Primary. Right, that should be sufficient instead. Get data should be way nicer as well, so we should just be able to do data type dot texture index dot get pixel data color 32 0, and here we do get index xy type, and then finally we do type dot channel index right. Set data still sucks, but I think we can move this one up here. Beautiful. I think index, we want to get index data array, we want to get although I wonder, old data, and then we can just do data array index value old data like this. I would have liked to skip the switch case here, if it would be possible. We could do... Probably gonna need a switch case somewhere, I think. But would be nice to skip the switch case here and do it here. So to color 32 terrain data type, because this one should control channel, texture index and stuff like that. Something from the outside shouldn't know about that, so we do to color 32. Let's do this, and then we do okay, so if we add a color 32, if we add a color 32 that has a red value of 255, and we add like a color 32 that has a value of 5, would we get, or can we even do it? Yeah, we don't have... makes sense. So... How do I want to get around this in this case? We want to... I want to be able to set a specific index. We want to have old values as well. 2 color 32. We want to do the switch cases in here, I'm pretty sure. We can have a method that is set. When it comes to height and grass, we currently do it solely on the GPU, and that's nice. Initially, we won't be able to do it like that on the for water as well, but that has already, or that has always been the goal. But for now, I definitely want these methods to be available, and I think I want them to be available later on as well, especially get specific data values. 100%. But you could do. I mean, we could do something like this. You could do something like this, and then something very similar. Here, so we could do add value. Still not entirely sure about this one. do it like this. Int math f clamp. We can't do that here either, actually. But old values dot r plus add value. Something like that. And or actually no. We could do old values. Type dot channel index. We can do it like this. New value. Maybe. So set data would be data array index is equal to type dot set value old data. Data alter. Inbounds, get index, get data array, get data, set data, alter data. And I'm still a little bit byte. I don't know if I want to send in byte here, or if we want to work with integers from the outside and clamp it here. In this case it doesn't matter because we're gonna do integer calculations here. We could do set data int value, and then we do set data xy type byte could do it like this. I think we're gonna do it like this. Let's see. I don't wanna convert to byte, then convert to int, then convert to byte. And we know, thanks to this, we're going to work with integers instead of bytes. So when we get to this point, we want to have an integer. So byte alter data int, worst case scenario, and fuck, when I think about it, this one could probably be better as an extension of color32 than actually type. But yeah, I don't know. Okay, so all of these are our entry and exit points for altering the data directly. Won't be able to do it any other way on the CPU at least. So we don't need set byte height, set get byte height, container, resolution. don't need this, we don't need this. This one, we're gonna replace all of these by these. Although, nah, it's okay. Fluid point byte. Yeah, here we want to do for now we're gonna do well, let's see here. Okay, if we start by jumping off to the second texture now, we're gonna do a few changes before we can try it again, but that's okay. Terrain data dot get data xy type. So we do like this. Doesn't that look nice? I think so. Although probably want the enum first. Get data, terrain data type, height at xy. Or get data at xy of type height. Pretty sure I want it the other way around. If I get the best part, or not the best part, there's quite a few good things with this. But one thing I'm looking forward to is to utilize this terrain data type in relations to terraforming later on. I'm gonna be able to clean up Terraform brush quite a lot, I think. Okay, so we do this. We still have a few issues to fix. Yeah, of course. First of all, this one. I think this looks way nicer. Get data height at XY. And then we have roof, raw fluid amount, raw fluid surface height, add fluid name recursive. Okay. Surface height we're gonna do it like this then instead. Raw fluid amount, so we're gonna do drain data, get data, terrain data type water, X, Y. And now it's the question, fluid amount or fluid surface height? What is this one going to represent? It's going to represent surface height, I think. So fluid amount, yeah, we do it like this. Okay, so this one will be this, and terrain fluid amount will actually be minus terrain data, get data height X, Y. Algorithm step 3, yeah, so fluid amount. Oh, this one is going to be so much nicer. Position world space. Yeah, that one, this one, and this one we still want. Height, we're gonna do get data we're gonna have to remake this one a bit. Height, foliage, water, and we're gonna do actually, what the hell, let's do get data. We could probably write a nice function for this one. Terrain data container, alter data, public string, get data description or get data info. And let's do this for now. So the idea is terrain data type. We're going to introduce a string representation of these. I think we have one by default that is just equal to these, and I think that's good enough for now. Maybe later on we will improve of it. Which actually makes me wonder. Yeah, we're probably going to add a toString method here, or description or whatever, and use that one. I'm a big fan of this as opposed to having specific functions per terrain data type and letting terrain data container handle all of that. Have this enum instead, but should have done it earlier. But that is unfortunately going to be it for today. I'm gonna do short streams this full week, and I gotta run now. But good progress, small but good progress. So thank you so much for watching, everybody, and have a great rest of the day. Peace.